The topic under discussion today is confidence interval. Before discussing confidence interval, there is one thing that I would like to remind you, and that is to revise normal distribution, because you cannot understand confidence interval without understanding normal distribution. So, before we start discussing confidence interval, let's talk about point estimate. So, a point estimate is a parameter used to estimate a population. For example, I want to work out the average weight of apples. I take a sample of 300, weigh those apples, work out their average, and that average would be a point estimate of the population, because that average is a representation of the mean, because I'm using that average, that mean of the sample, to predict the mean of the population. So if any parameter is used to predict a population, then that's, or estimate a population, that parameter is called point estimate. What is confidence interval? Confidence interval is a range, and it shows that the mean based on the confidence level. That's so let me explain it to you through an example, because it would get really complicated otherwise. So let's talk about a 95% confidence interval. Okay, so whenever I talk about 95% confidence interval of a range, that means that there is a 95% chance that my mean will lie in that range. So that means that if I take 100 samples from that range, then 95% of the time the mean of that sample will contain the mean of the population, but 5% of the time it will not. Okay, so if I talk about 99% confidence interval, then if I'm taking 100 samples from that interval, 99% of the time those samples will represent the population mean, but 1% of the time they will not. It is a chance that the sample will not represent the population mean, will not contain the population mean. So as the bigger the confidence interval, the more is the chance that it will be a representation of the population mean. In order to summarize, a 95% confidence interval has a 0.95 probability of containing the population mean. As we already know that in a normal distribution curve, 68% of the data lies within 1 standard deviation, 95% of the data lie within 2 standard deviation, and 99% of the data lies within 3 standard deviation. Why am I discussing this? I'll let you know. So you know that this is how a normal distribution graph looks like, but what I am interested in is my data. I am looking for 95% confidence interval. So basically, this is how normal distribution curve look like, but I'm interested in this curve, that my data has a z-score of plus minus 2. That means that the probability of the data lying within that distribution is exactly 95%, whereas this graph represents a probability of less than or equal to 0.95, but all I'm interested in is exactly 0.95. So how will I work it out? As you can see that this graph has this bit extra, so I have to get rid of this blue bit. If I look at the normal distribution table, it gives me less than or equal to the probability D. So all I have to do is I already know that it's symmetrical, so this would be the same as this, which doesn't look the same in my curve, but it is the same. So if I get rid of this blue bit, I will end up with this. I will end up with my curve that I'm looking for. So what I do is, I know that this whole curve is 1 or 1, probability is 1, and if the probability of the colored area is 95%, then the remaining probability is 5%. Okay, because the curve is symmetrical, it would be 2.5% either side. Okay, so what I do is I take out 2.5%, okay, 2.5%, which will get rid of this curve, and now I am left with my original curve, the one that I'm looking for. Okay, so the first step would be to do 1 minus 0.95, which is 2.5%. 5% divided by 2, which is 2.5%. So from this curve, which is which was till 0.95%, I took out 2.5%, which is this, and I'm now left with this. After doing that, I am left with the probability, the score of 0.975%, the probability of 0.975%. I go to the table of 0.975%. I follow 0.97 from the extreme left side and 0.005, and then I get the z-score of 1.96. I substitute the z-score in the formula, where it is mean plus minus z-score s over root n, where s over root n is the standard error and it is a measure of dispersion, or how far away the mean is, the sample mean is from the true population mean. I substitute it back in there and I will get my confidence interval, and that's it. So whatever is a confidence interval, if it's for the 95%, then that means that 95% of the time my true population mean will lie within that confidence interval. You can go through these steps again and you will understand it, hopefully. Thank you.